Welcome back. Now we are looking at section 2.6, which is about transformations of functions. In mathematics, we say a transformation is a change in the shape or position of a function of an object. And our object here will be functions, or basically graphs of functions. Now there are several kinds of transformations, but we will study only three here, which are translation, reflections, and uh, stretches. So we will have a vertical translation and a horizontal translation, and then reflection about our vertical axis and reflection about our horizontal axis. So what is the horizontal axis? The x-axis, and the vertical axis will be y-axis. So these are translations and reflections. Okay? So in general, let's look at this example that we are given a function. We know that our function f of x looks like absolute value of x, actually is the absolute value of x. Then we want to sketch the graph of these functions, which are a little bit more uh, advanced or more complex than just absolute value of x. So we have absolute value of x plus 2. So we can make a sign, table of values here, like I did over here for this function and over here for the other function. But the thing is that what we notice after graphing them, that the absolute value of x plus 2, absolute value of x plus 2 is just a shift of the absolute value of x graph up 2 units. So see, this blue one is taking the black graph, which is the graph of absolute value of x, and moving it 2 units up. So each point on the graph has been moved 2 units up. Okay? Any point that you take on the graph, it has moved 2 units up. So that's what we call shift up, or a vertical shift up. Okay? So instead of making the table of values, if you know the graph of your basic, the shape of the graph of your basic function, which in this case is absolute value of x, then anything which looks like absolute value of x plus a number, it means you just take the function absolute value of x and move it the whatever the number was, so many units up. Then if we have absolute value of x minus some number, then it will make sense to assume that it will move the graph of absolute value of x below its 3 units below it. So you notice each point on the graph of the absolute value of x have moved 3 units down to give us the graph of the absolute value of x minus 3. So for example, this point 1, 2, 3, it's 3 down. Any point you take on it has gone 3 units down. So general, now we can say, so this is how we will do the problem. If we have to graph it, we will first indicate our basic function, then we will indicate what is the translation used, or what transformation has been used, and then sketch the graph. In the second example, now I am taking another base function. If you notice, what is the base function here? Base function is again absolute value of x, and then we are trying to find what is the absolute function graph when the function is absolute value of x minus 2. So previously we had absolute value of x minus 2. So see the difference here. Then now the minus 2 is with x. 2 is being subtracted from x in here. whereas in this function 2 was being subtracted from the y value. Now here the 2 is being subtracted from the x value. So what does it mean? Let's check. So we have the graph of absolute value of x shown here in black. Okay, and now I plug in and graph the function mx, which is absolute value of x minus 2. And what do you notice? Every point on the graph has moved 2 units to the right. So when you have x minus the number base function, so if we say the number is being subtracted from x or subtracted or added. Okay, so here we have now, we call it the horizontal shift. So the previous two were vertical shifts. So we say the first one was shift up 2 units, the second one was shift down 3 units. Now, what is this giving us? It's still giving us the base function is square root of x, absolute value of x. So in the function x minus 2, we notice that the graph shifted. So shift or move or slide or yeah, so these are the words that you can use. Shift 2 units to the left, or shift left 2 units, or sometimes students just write left 2 units, which is okay. But I like writing it this way: shift right 2 units. In the second case, in the pink graph, which I have not drawn the whole graph, but notice here I took my usual values, the -2, -1, 0, 1, 2, but I am not able to see, but okay, I am able to see this much, that the graph is bending now at -1. We are getting this piece, so we want a few other values on the left of that. So we can extend our table of values and calculate for -3 and -4. So at -3, the value will be 2, and at -4, the value will be 3. So -2, -3, the value is 2, and -4, the value is 3. So now I can send this over here. So now what happened? It looks like the graph shifted 1 unit to the left. So this thing shift left to 1 unit. Now another pair of graphs. So now we have p of x is equal to absolute negative of absolute value of x. And the next one is absolute value of negative x. Now we again make our table of values, and we see our blue graph here, down here. What is this? If you recall, the graph of absolute value of x and compare it with this one, the blue graph, then this is just a reflection of our function about the x-axis. So we also say flip over x-axis. So the base function here is so you can see already base function is the absolute value of x. And what does the negative sign in front does? Flip over x-axis. And the pink one, what is that doing? Basically, we are getting that this is the same thing as absolute value of x. So it is not changed anything, but actually this is flip over the y-axis. Because this graph is symmetric, the absolute value of the function has a symmetric graph, so the reflection about the y-axis is not showing any change in the function here. Now so these two are what we call reflections. These two examples showed you the horizontal shifts, and the first two showed you the vertical shifts. Vertically shifting up, vertically shifting down, horizontal shift right, horizontal shift left, reflection over x-axis, reflection over y-axis. So now look at some example. Now this is the more elaborate definitions of the shifting. You may read them in your own, and these are more elaborate definitions of the reflections. Okay, so now it's question example using transformations. So this is important. Using transformations, sketch the graph of the following function. So we have to sketch the graph of each of these functions, but we must use transformation, which means we cannot use our table of values. So you are not supposed to make a table of values. So first thing you have to figure out is what is the base function. So in part 1, the base function is I hope everyone can recognize is x squared. That is our base function. And this is saying x squared plus 2. So what did we just see? That if you are adding something in the function value, then it moves the graph of the function so many units up. So we are adding 2, so it means we have to move the graph of x squared 2 units up. If you recall, the 3 points at which we use to graph the x square. So the graph of x square will look like this. Something. We don't have to draw this one, but if you want, you may. But it looks something like that, right? So we have to shift it up 2 units. So if you become, go here, 1, 1, and then now you need more space on the top. So if I'm graphing it on my own without the grid here, I will put this horizontal line down the x-axis down below over here. So if this is my x-axis, then I can have enough space to show the graph of the given function. Okay, on the right here we have, okay, let me draw the graph by the way, whatever space we have. So this will be the graph of x squared plus 2. So now the second part is g of x is equal to x minus 1 whole cube. So what is this? This is we have a number which is being subtracted from x, and this is the so base function here is x cube, and this 1 is being subtracted from the x value, so this is a horizontal shift. So you can say horizontal shift to now you have to recall whether it's to the right or is it to the left. The quickest way to figure that out is what value of x will make this quantity 0. Well, you can see x when x is 1, this will be 0. So it means you have to shift to the right, okay, because you got 1, which is a positive number. So you have to shift 1 to the right. Shift right 1 unit. Okay. And base function is x squared. This was shift up 2 units. Shift right 1 unit. Okay. Now we call the graph of x cube. We are now going to move it 1 unit to the right. So x cube graph looks like, at 1 it is 1, at 2 it is 8. Now I don't have that 8, access to 8. A negative 1 it will be negative 1. So but I know that shape goes something like this. Something like that. So now we have to shift it 1 unit to the right. It means this point will go there. This one will go there, and this will come here. So we will have something like that. Okay. So that is how you after. So what has happened is we shifted right to here. Okay. So we now here I showed you single transformation. We can have more than one transformation in a function. The important thing is to be able to recognize the base function and then also the transformations used. So this note can be written as, this can easily be written as square root of x plus 2 plus 1. Okay? So which means whatever the graph of square root of x plus 2, we will have to eventually raise it 1 unit up. So this is giving us the transformation 1 unit up. Okay, so we start with the base function. So base function is square root of x. So starting from inside here, so the factor square root of x plus 2, what does that give you? Shift left 2 units. Then plus 1 gives you shift up 2 units. So shift up 1 unit. Which means when we graph the function, so this over here now I don't have those graphs. So now your graphing paper, the grid. So I want to show you how you will do it in your notebook. So first things you have to notice that it is being shifted to the left and it is being shifted up, which means probably, and the square root function you remember has the domain from 0 to infinity, but it has also the range from 0 to infinity. So we don't have, we will not get negative numbers. So we can leave less space at the bottom below the x-axis or at the bottom, and then more space on the top, and again less space on the right, because the plus 2 is going to shift the graph to the left, so we need more place to the left. So I will not create a grid which is symmetric like the ones I gave you up here, these ones. So I'm going to use the information or the numbers that I have. I'm going to use those to create my grid or my coordinate axis. So I can have my y-axis over here and x-axis right there. So then I'm going to put the tick marks and the numbers. So like the tick marks to the left are bigger. Make them a little smaller. So now we have to graph the function. We have to have some tick marks over here. Okay, and now remember our original graph. If we drew it, it would be something like I'm graphing it using a dashed line. Okay, so now we have to shift this 2 units to the left. What does that mean? It will give me, so it will shift all the points, remember those 3 points to the left. So when you shift the 0, 0 to the left, we arrive at -2. And then the one will go to -1, 1, and the 4, 2 will go to 2, 2. And you can have the, so you can also do these problems like this, that you graph, you must write the transformation and the base function. That is something you must. When the question says use transformation, you must state what is the graph, the base function, and what are the transformations being used. And then you can graph your final answer, final function, or you can do it in between here, like I'm doing here. So you can say this one is square root of x plus 2, but that is not what we want. We want to raise it now 1 unit up above. So now I'm going to use another color. Okay, so this will go 1 unit up somewhere here. This will go 1 unit up. This point will go 1 unit up. And now our graph is starting at this point. So this will be your final graph. This is how it will look like. So now I'll let you guys try the last problem over here, and then I'll come back and see how you did.